Hello everyone. In this lecture, I am going to discussing about the example problem on stresses due to the shrinking. So this is I will discuss with one example problem. Let's see the problem is a thin tire of steel is to be shrink on a rigid wheel of 900 mm diameter. Calculate the first one is internal diameter of the tire if the hoop stress is limited to 120 Newton per mm square. And second one is the least temperature to which the tire must be heated above that of the wheel before it could be slipped on. And for the tire, take coefficient of thermal expansion, that is the alpha equal to 12 into 10 to the power of minus 6 per degree centigrade, and Young's modulus, that is equal to 2 into 10 to the power of 5 Newton per mm square. So let's see the solution. First we have to note down the given data. So in the given data, that is given the wheel diameter, that is given 900 mm. So let us consider capital D, and also given that one the hoop stress value is given, that is let us consider sigma h equal to value is 120 Newton per mm square. So and also given that one the coefficient of thermal expansion and Young's modulus for the tire material, that is the steel, values are given. So first I have to note down the given data. So that is the wheel diameter capital D 900 mm. So hoop stress sigma h equal to 120 Newton per mm square. So coefficient of the thermal expansion, that is alpha equal to 12 into 10 to the power of minus 6 per degree centigrade, and Young's modulus, that is the 2 into 10 to the power of 5 Newton per mm square. So first we have to find the first question, that is the internal diameter of the tire. So first we have to calculate the internal diameter of the tire if the hoop stress is limited to 120 Newton per mm square. So hoop stress is given, we have to determine the internal diameter of the tire. So we know the relationship between the hoop stress and wheel diameter and the tire diameter. We have the formula in the previous lecture already we discussed. So then the hoop stress sigma h equal to capital D minus small d divided by d into Young's modulus of the tire. Here capital D equal to wheel diameter, small d is the tire diameter, and E equal to Young's modulus of the tire. So sigma h, that is the hoop stress, equal to d minus small d divided by small d into Young's modulus of the tire, that is the 120. So here we know the wheel diameter we know, Young's modulus of the tire also we know. Then substitute in this equation. This equation will become 900 minus small d divided by the small d into 2 into 10 to the power of 5 equal to 120. So here once again we have to write down this equation. So 900 minus small d divided by small d equal to 120 by 2 into 10 to the power of 5. This value will become 6 into 10 to the power of minus 4. So this equation once again we have to write down the 900 divided by d minus d by d, that is the 1, equal to 6 into 10 to the power of 4 10 to the power of minus 4. So this equation once again we have to write down 900 divided by d equal to 1 plus 6 into 10 to the power minus 4. So from this one we will have to calculate the d value. So that the d value equal to 899.46. So next to see the second question. So here we have to determine the temperature rise to increase the tire diameter up to the wheel diameter. So let us consider the increase in temperature, let us consider capital T. And here, so when you rise in temperature for in the tire, so initially the diameter is d, it will be expand and the diameter it will become the equal to the wheel diameter, that is the capital D. So when you increase in the temperature, that is the capital D, so its diameter increases from small d to capital D. So here we have to write down that one. So final length of the tire, see here tire is expanding from the small d to capital D. So due to the temperature rise, capital T. So here we have to say that when the final length of the tire equal to initial length of the tire plus expansion due to the temperature rise. So what is the final length of the tire? It's the final diameter is the capital D. So how to calculate the length of the tire? It should nothing but perimeter of the this one. It should be the pi d. So pi d equal to initial length of the tire. It should be the initial perimeter of the initial one. So that is the pi small d. And expansion of the due to temperature rise. We know that when the expansion due to the temperature rise formula we know L alpha T. So here L is nothing but perimeter of the tire. So at initial condition. So it should be the pi d. At initial condition it should be the small d. So perimeter it should be the pi d alpha into capital T. So this equation once again you have to write down the, so pi d equal to here pi small d you have to take the common, it will become 1 plus alpha t. So here we know the capital D, that is the wheel diameter, that is the 900, and small d, so from the previous one we determine the, so tire diameter, that is the 899.46, have to substitute here, and 1 plus alpha value also given in data, that is the 12 into 10 to the power minus 6 into capital T. Then this equation once again it will become, so here pi it will be cancelled, then 900 divided by 899.46 plus 1 plus 12 into 10 to the power minus 6 capital T. So here once again you have to write down, so 900 divided by 899.46 value is 1.0006, here it will become minus 1 equal to 12 into 10 to the power minus 6 into capital T. So this is once again you have to write down, so 6 into, so 10 to the power minus 4 equal to 12 into 10 to the power minus 6 equal to capital T. So here capital T it will become the 50 degrees centigrade. This is only the question is asked for that one. So calculate the temperature rise. So this is the solution. So thank you.